Hello friends, welcome to another problem solving video. Now today we will be solving this problem of generate binary numbers from 1 to n, okay, in an efficient way. So let's jump to the problem statement. So we are given a number n, okay, and you have to generate all the numbers from 1 to n in binary, okay. So suppose you are given the input 15, then we have to generate all the numbers from number 1 to 15 in binary. So these are all the binary numbers from 1 to n. So how do we solve this problem? So let's see if we can find a pattern in generating the binary numbers. Okay, our approach would be to generate in order of n. Okay, let's see if we can find a pattern among these generation. So let's say when we take 1, how can we generate the next two numbers? The next two numbers can be generated by adding a 0 and a 1 to this number. Okay, when we add 0 and 1. So how do we generate the next two numbers? So the next two numbers can be generated by adding a 0 and a 1 to this number, and so on. So the next two numbers can be generated by 1 1, adding 0 and 1 to 1 1. Okay, so this is like this, and the next two numbers we can use by adding 1 0 0 0 1 0 0 1. I hope you get the pattern in this. In this way we can generate all the numbers from 1 to n. Okay, so to do this we use a queue data structure. Okay, and let's jump into the code to understand how to use the queue to generate these numbers. Okay, so here is the function signature, which returns a vector of strings. Okay, which returns a vector of strings and takes input n, which is the number of generations for binary numbers from 1 to n. Okay, so we start with queue of string way of nums. Okay, empty string, empty queue, and we have a result vector, right? Initially we push 1 to the queue. Okay, we push 1 to the queue. Now from 1 to n we iterate, so the queue will currently have 1. Okay, now we take this number temp is equal to 1, we push back into the result. So let's say this is the result vector, so the result will have 1, right? After that we pop the queue, so this queue becomes empty. Then we push one appending 0 to 1 and 1 to 1. Okay, now I is 2. Okay, after incrementing again we take temp is equal to the first element, we pop the queue, so temp becomes 1 0. Okay, now we push this into the result. Okay, so this will be pushed to the result, and then we pop this element out, that is we only have 1 1 in the queue now, and we push, since temp is 1 0, we push 1 0 0 and 1 0 1. Okay, so now I will be 3. Okay, so again we take the front element which is 11. So now temp becomes 11. Okay, we pop the Q. Okay, so the Q will now look like this, and we add 1 1 0 and 1 1 1 into the Q. Okay, so we keep doing this until n numbers we have pushed into the result, right? In this way we will be able to print all the numbers from 1 to n. Okay, so what is the space complexity of this problem? Space complexity. So the space complexity is basically we are using a queue of numbers, okay, and a result vector, right? So this queue can be of order of n. Okay, since we are pushing finite elements for each element. Okay, and we stop as soon as we find n elements, right? So the queue can be maximum of n plus 2 elements, which is order of n, right? And what is the time complexity? Time complexity is we are running this loop from I is equal to 1 to n, so the time complexity will be order of n. Okay, can we do better? uh, in C++ we have something called as bit sets. So how this works is bit set is basically a binary, stores internally a number in binary. Okay, so when we are saying bit set and we are saying 8, it means we have created a binary number of 8 bits, right? 8 bits, and we are instantiating it with the number 1, so it will store the number 1 in binary. Okay, 0 0 0 0 0 0 0 1. Okay, in the first iteration when I is equal to 1, and to print that number we simply have to do toString, okay, to the result, and we keep doing this until I is equal to n. So let's say for n is equal to 4, it will print 0 send 0 0 0 1 0 0 0 0 0 0 1 0 0 0 0 0 0 0 0 1 1 0 0 0 0 1 0 0. Okay, so this is how it will print, give us the result. So what is the time complexity? Sorry, what is the space complexity first? The space complexity, if we consider the result, then it is order of n. Otherwise, if we are not considering this, the space complexity is order of 1. Space complexity. And what is the time complexity? You might have already guessed it. It's order of n, since we are iterating from 1 to n, right? I hope you understood this problem. Keep watching for more such videos. Thank you so much.